Hello and welcome to another one of D's ADD videos. Today we're going to be looking at drawing the Lewis structure of the sulfide ion, or sulfur trioxide if you're practicing your naming rules. These are two nonmetals, use the prefixes. So in drawing the Lewis structure, these are both in column 6 on the periodic table, oxygen and sulfur. So they have a valence number of 6, and so we would have 6 for the sulfur plus 6 times 3, or in other words 6 times 4, which is 24 electrons. So set up your skeleton structure. We're going to have a sulfur with 3 oxygens, and here we're going to have a single bond to each oxygen to start out with. And right away you should notice that sulfur doesn't have a complete octet, so you could either try getting a lone pair added here and then adding lone pairs everywhere, or add a bond. Those are your choices. Sorry about the squeaky toys. I just got my puppy's squeaky toys. Bad idea. Alright, so here, if I do it this way, let's see what happens. I'd have minus 6 bonding electrons, and then I'd have 18 lone pair electrons left over. And the thing is that each of these oxygens, as they sit, would require 6, and that's not going to work because we wouldn't have these 2 available for the sulfur. So let's try adding a double bond. So if I put a double bond arbitrarily on this oxygen, then I have 8 bonding electrons that are removed, which would leave me 16 lone pair electrons. Let's see how that works. Notice that sulfur's octet is satisfied. So here we have 2, 4, 6, 8, 10, 12, 14, 16. So that does look like it worked. Let's see if the charges work. So we need to be neutral. This formal charge on the oxygen is going to be 6 valence minus the 1 bond plus the 6 lone pair electrons is -1. So that means that this has a -1 charge. Oops, sorry about that. And then this one has a -1 charge. Let's look at the sulfur. Hopefully it has a +2 charge. Now it has 4 bonds and no lone pair electrons, so it does have a +2. So this is a valid Lewis structure because the net charge is neutral and the electrons match up. Now the question is, can I get a better Lewis structure by adding another bond, or maybe another bond? So we want the most bonds, the fewest formal charges. So let's try the 2 bonds. Two double bonds, that is. this scenario, we still have the 24 electrons. Now I have minus 2, 4, 6, 8, 10 electrons. Notice I do have more than the octet in the central atom because sulfur is on the third row, so it has access to the d orbitals and therefore can get larger. So here we have enough with the squeaking. Bad idea getting the toys. Alright, so here we have 2, 4, so let's see what the charges are now. The oxygens with the double bond, we'll call them O sub D, is going to be 6 minus 2 plus 4, which is neutral, and then the formal charge of the oxygen with a single bond is 6 minus 1 plus 6, which is a negative 1 charge, and then the formal charge of the oxygen, or sorry, the sulfur, is going to be 6 minus the 5 bonds plus no lone pairs equals 0. So I never checked my lone pairs, 2, 4, 10, 14. So yes, that does match up. So this is a minus 1, this is a plus 1. Alright, so already this is a better structure than this one because this one had 1, 2, 3 formal charges and 1 double bond, and this has 2 formal charges and 2 double bonds. Okay, so there are fewer formal charges and more bonds, so this is more valid. So we might as well just try the triple double bonds, the 3 double bonds, see if that works best. So we have sulfur, oxygen, 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 and then if we do this, here we're going to have six for the valence of sulfur minus the 6 bonds plus 0 lone pairs. Oop, forgot to draw my lone pairs, didn't I? So the 24 minus the 2, 4, 6, 8, 10, 12, at least 12 lone pair electrons, which are neatly going to go on each one of these guys. So the formal charge on the oxygen is going to be 6 minus 2 bonds plus 4 lone pair electrons, and I don't need to repeat this calculation at all because it is the same oxygen, right? It would still be 2 bonds, 4 lone pairs. So in this case we've got no formal charges, everybody's happy, and they have the most bonds, so this would be the most valid structure there is. Alright, so you can see that just because you get something that matches up all the rules doesn't mean you should stop. You try adding more bonds. Alright, you got to do as many of these as you can to become really good at Lewis structures. And again, if you're not good at this Lewis structure stuff, when you come to Vesper theory and drawing 3D geometry, you're going to be in trouble. Alright, so practice, practice, practice. Thank you and have a nice day.